All right. Hello, everybody. How was your DevFest?
Awesome. Very good.
Yay. Awesome. So today we're going to be talking about test-driven development, specifically in the context of Dart and Flutter. I think there was a Flutter talk in here or out there just recently. But at any rate, so if you're unfamiliar with test-driven development, we're going to be going through kind of a beginner's guide on what TDD is and kind of how to implement it a little bit at a time. And if you're not familiar with Dart either, that's okay. As long as you have just a little bit of programming experience in general, I'll go over some of the nuances of Dart as we go through the talk. So, my name is Stuart. My Twitter handle up top is StuartSoft. These slides are available right now on my Twitter handle, they're the most recent post. I'm a full stack developer at a company called StackCT. It's a website that is used by construction estimators, basically. So you can upload blueprints, and they can do annotations and estimate the cost of doing particular jobs. I'm also a part-time developer with the Rotor AI project. It's myself and a few friends based out of Dayton, Cincinnati kind of area. And I'm a graduate of Grove City College, 2016, computer science program. And so TDD plays a big role in my everyday development at Stack. It's a fundamental aspect of just about everything that we do from just in terms of our daily cycle every single day. So I wanted to bring some of that over to the Rotor project itself as we started developing that product as well. Which, just as a disclaimer, Rotor is not affiliated with my employer, Stack. They're completely different. Rotor is, it's really just kind of a hobby project, so to speak. So, Rotor AI, the project itself, it has the main goal of the project is to eventually develop a self-driving, autonomous RC car. It's a very long road ahead of us, pun. But anyways, we started about a year ago, myself and a friend over at a machine shop. And it's kind of, the project itself is composed of four code bases. The one that we're going to be going over today is just the Android and iOS app that we use on our phone to connect to the vehicle itself. So if we need to manually manipulate the vehicle for whatever reason, stop, start, move left or right, that was one of the basic things that we wanted to get down before jumping into the AI component of itself. So, test-driven development. Who has heard of test-driven development? Who uses test-driven development at work or anywhere? All right, got a handful, cool. So, for everyone, the test-driven development is effectively, it's a style of coding wherein you are writing unit tests or integration tests at the same time that you are writing the source code itself. So there's a cycle graph that we'll go into in just a second, but it effectively is you are writing tests that define the behavior that you want to see from your program, and then you are implementing that actual behavior in actual code. And there's a couple benefits to using TDD in your everyday work cycle. It kind of provides an avenue for self-documentation. So if you have a new developer coming onto the team and they're unsure of how this particular function operates if you give it a particular input, you can point them to the test cases, and there should be a test case that defines, well, given this type of circumstance, I expect this output. Additionally, it kind of gives you a test suite by which to ensure that new code that you're writing is not breaking existing functionality. And so that becomes increasingly more important the larger your project gets, because when you are shipping out an update, you want to make sure that none of the code that you've changed in the last week or two is going to break any of the existing features that you've had for the past year or two. So, and in some cases, it's impractical to test the thousands of use cases every single time you deploy. So that's a big part where testing comes in. So the typical cycle that you can kind of walk through is kind of as follows, starting up with the writing tests up here. So you're initially starting, I usually start with my editor with 2 files open. And on one side, I'll have the actual code for the app, and then on the other side, I'll have a test. And I start by defining my test, writing out my most basic test expectations, and that defines the behavior that I'm wanting to see from my app. I then go to the next step. I run the test to make sure that it fails, because it's expecting behavior that I didn't write yet. I then go ahead and switch over to my other side of my editor, implement that actual code, and then I run my test again, and it should pass, because I have now implemented the expected behavior. And then you can go back and optimize or change anything. Let's say if you were using a standard for loop to go through something, and actually, well, I could actually do this with like a .for each or something like that. You can refactor that and go from green to green. Green being the test is passing, red being the test is failing. So Google has, on the Flutter website, they have 3 main categories for testing: unit testing, widget testing, and integration testing. If you've done testing before, if you've done TDD before, the first and last categories are probably familiar. Widget testing is kind of this in-between category, wherein you can test that things are appearing on screen or appearing on your widget as expected, and it kind of toes the line in between full integration testing and unit testing, in my opinion. Unit tests are your most basic level tests. You want to have the majority of your test suite should be unit tests. They run very quick, and they're easy to maintain. On the other end of the spectrum, you've got integration tests, which are usually checking that your app is working correctly with, say, if it needs to call a particular service or upload something or download something, that multiple segments of your app are all working together correctly. And those integration tests are usually the slowest to run and the most costly to maintain, and then sometimes they can be kind of brittle to maintain as well, so sensitive to particular adjustments in the app. OK, so let's start out with a quick unit test example. And what I'm going to do as I'm going through here is I will kind of define what the objective is for the test before we actually go into the test, just to help clarify. And on that note, I would also like to point out where you can put test files in a Flutter app, for example. So down here I have VS Code. And typically, what I've done is I'll have the lib folder, which is auto-generated when you create the Flutter project. That's where your Dart source files will be. And in this case, I have a RotorCommand class. The test for that same file will be in a parallel directory under test/data/RotorCommand. So that's just kind of a quick how-to on where those test files should be located. OK, so let's set our first objective. When we're using the Rotor app on our phone, again, we want to be able to send commands to the vehicle. This was kind of from early on in the project. We wanted to be able to manually control the vehicle. So let's make a class called RotorCommand, and it should represent the values that we want to send to the car. So in this case, it should represent the throttle and the steering values. The throttle will have a magnitude and a direction, and the steering will have a magnitude and direction. These values should be defaulted by the constructor. So we just want to construct it and check that it set the values automatically to an expected default value. And we also want to add a method that allows us to encapsulate the data from this class and turn it into a string that we can send over Bluetooth. So we'll go through each of these as separate coding exercises. OK, so this is kind of an illustration of what I usually do with my workspace. Again, I've got my actual code is on the left, and my test code is on the right. And most modern editors, you can split the interface. And IntelliJ and Android Studio and VS Code all have ways of just splitting the editor so you can see them both at the same time. It's awesome. So anyways, we've got a bare bones implementation of a class so that we can just compile everything, but there's really not much happening here. And we're going to start off by writing out our first test case. You want to give it a name that kind of describes what it is that you're expecting to happen. So in this particular case, I usually start my titles with should, do, X, Y, and Z, when something happens, or something to that effect. But again, it's just like a real short sentence that describes what you're trying to evaluate. So we should construct this object with default values. Our 3 major steps for each unit test is an arrange step, which is setting up our preconditions, our act step, which is actually performing some sort of action, calling a method, calling the method that you're actually going to be testing, and then the assertions at the end, which say, hey, this thing is actually equal to what it's supposed to be. So we've already got our arrange step. It's just setting up the command itself, just newing up a command. And we want to go ahead and write and expect. So if you've used other testing frameworks before, you might be familiar with like assert dot is true or something to that effect. Dart uses expect. You give it the first value is the actual value from the object that you're testing, and then the second is an expected value. Interestingly, you can put matchers in on that second parameter. So if you need to compare your test object and say, I don't know what value it is, I just want to make sure that it's not null. Or I just want to make sure that this object is the same instance as this other object. Or I want to make sure that this object is of type X. Those are all examples of matchers being used as a way of just asserting that certain conditions are met by your test object. So in this example, we're just going to expect that the throttle value is set to 0. And we'll put in some other expectations as well, asserting that the heading value is 0 and that these two are neutral. So what do you think is going to happen? It's going to fail? Why?
The throttle value is not right.
Yep. And when we run it, you can run your whole test suite just by running Flutter test in the terminal on the root directory of the app. In this case, there was only one test case. So we go ahead and run Flutter test. We see that it was expecting 0, but it actually got 2. So then this is the part where we flip over to the other editor, and we change that 2 to a 0, and we're good to go. And so that's kind of one. You've just seen one iteration of that TDD cycle of developing the test, running it, it's red, fixing it on the other side, and then we run it again, and it's green. Or so it would be. We run it again, and it goes down to the 3rd expectation. So it passed these first 2. It runs down to the 3rd expectation, and it's saying, hey, what the heck? I was expecting a neutral value for that. You actually gave me null. So again, same sort of situation. We flip back over to the other side of the editor and set that to neutral. And now our test passes. And that is a complete TDD cycle there. OK, so next steps. We wanted to write a method that basically encapsulates all of this data from our rotor command and mushes it into a string that we can send over Bluetooth. The desired format is we basically want a single character to represent the throttle, and then 3 digits to represent the throttle value, followed by a space, and then a single character representing the heading, and then 3 digits representing the heading value. And I'll have an example right here. So given a particular situation that we have a rotor command with a throttle of 77 going forward and a heading of 55 going to the port side, because I was feeling silly and I wanted to use port instead of left, but at any rate. So we're going to, on our rotor command, we would run toShorthand, and that's the method that we're going to, that method would convert it out to the following string, F077, et cetera. This toShorthand, I broke it apart into 2 smaller methods, throttle toShorthand and heading toShorthand. So this throttle toShorthand will just build the left half, and this will build the right half, and then they're just concatenated together and output by this main method. So let's TDD this throttle toShorthand real quick. apologize if it's a little bit small. So again, setting up our editor. On the left, we have our real code. On the right, we have our test. We're going to go ahead and put together a test case for, we're going to say we should produce the correct shorthand based on the throttle direction. So in this particular, remember how I mentioned the arrange, act, assert? In this particular test, I've kind of folded all of those into one line. So we're writing out our expectations. We're expecting a new rotor command. This is newing up a rotor command. It's providing it with a throttle direction of neutral, and then it's running our throttle to shorthand method, and it's going to expect N000. So if you're looking at the code on the left, this isn't going to work. It's going to be like, hey, I'm expecting this, and you gave me an empty string. So we go ahead and implement the minimum fix required to get that assertion passing. We're all good. As long as we don't need to go anywhere, we're good. So that passes, and we'll add a few more assertions because we actually do want to go forward and backward. So in the event that I new up an object with a forward, I should get an F. In the event that I want to go backward, I get a B. And we fail right there on that first line. So let's go ahead and implement that. There's a big jump here. It's effectively, the fix for this is effectively to implement our switch statement for that abbreviation. So if we're going forward, let's use an F, backward, B, etc. And again, you notice at the bottom, we're just outputting a string of 3 zeros. We just want to make the minimum changes here to get this test passing. So, that's all we need for now. And we go ahead and do that, and we're golden. So we've gotten the first half of that string. Now let's actually take care of some of the throttle values. So again, new test case. We've got four different assertions here, and we'll just ballpark some numbers. We'll have a 0, we'll have a single-digit number, a 2-digit number, and a 3-digit number. All of these should be output with 3 digits, so keep that in mind. Which line do you think it's going to fail on when I run this test?
Second.
Yes, because we already had an expectation for that up here, first of all, and it's kind of optional, honestly. I kind of just put it there, I guess, as a default case, but yes. So we go ahead and run that. It's going to fail on the second line of that test. This is kind of interesting. It's hard to see because at the bottom, but it will actually show you where the string comparison diverged. So it's like, hey, I expected this, but you actually gave me that. It was the first 3 characters were the same, and that's where it diverged. So maybe that's helpful. It might be more helpful if you were trying to maybe compose a string for a UI, perhaps, and you were trying to say, like, I don't know, welcome Stuart or welcome user, and those were the two. One was the expectation, one was the actual. You could say, well, they both said welcome, but the name was wrong. So anyways, string comparison. So to go ahead and fix that segment, we're going to import the Intel library, or Intel package, excuse me, which gives us access to number format, the number format object. And we're just going to set, hey, I want a minimum and a maximum of 3 digits all the time. And this is just going to format that number, and we're going to concatenate that out. Now, it's interesting to note, it's interesting to note this is actually a private method. So Dart's way of defining private methods is just to have a prefix with an underscore. So just if you haven't caught up with or used Dart before, that's just one of those nuances. And that test passed. We're all good. All right. You have a question?
What if you put in a negative number or a number larger than 4 digits?
If you put in a negative number or larger than 4 digits, we could experiment with that. I think, I don't know. It would be interesting to see. That would be a prime example of using a test case. That's the type of thing where you would want to write a new test case for that particular situation that you just described. Because it might be an edge case that, oh, somebody happened to construct a command with a value of 1,000. Let's make sure that that's outputting the correct value because we don't want it to go over 1,000. So there were test cases, I think, for that I had for truncating the value, so between 0 and 100. But that's a prime example of writing a new test case. OK, so if you've used TDD before, another situation that you might run into is needing to mock an object. And you might need to mock an object if you need to, say, you have some external dependency, some external class that it's technically needed to run your test. Your test depends on it, but you really don't care so much what happens behind the scenes with that object. You really just need it to be there and maybe provide a little bit of information. So mocking kind of allows you to create this version of the real class, but you can kind of just hand it specific values that you want it to return or behave with. Mocking also allows you to do things like verification. So if you want to verify that this class that you're testing called some other service, you can do that usually by mocking. So if you've used Mockito for Java, there's Mockito for Dart. Simple way to put it. Mockito is just the library itself for mocking. They have pretty simple syntax. It's basically just when this particular mock method is run, I want to return some particular value. You can use this with futures too. Futures are kind of like objects that represent work that's going to be completed. So if you need to mock out a future, you can say when this particular method is called, then return, and then put in a Lambda method. OK, so let's put together an objective for testing with mocks. We can begin by, we want to start scanning for Bluetooth devices to connect to it when we open the app and we press the main button on the screen. But we don't want to start scanning if Bluetooth is off, for example, because why? So we have one major dependency here, and that is the Flutter Blue object. Flutter Blue is a Bluetooth library that we're using for our Rotor project. And we need to verify that the flutterblue.scan method was called. But again, only after Bluetooth is on. So creating your first mock. It's very simple. You just define a class, and then extend mock. And then you implement the class that you are wanting to mock out. I have a designated file in my example. I have a designated file in my project just for mocks. So it'll just be class, 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 class. It seems like a convenient way to at least store it for now. But wait a minute. You can implement a class? Well, it turns out Dart has an implicit interface for classes. It's another one of those Dart nuances. So it was kind of something that was noticed when this presentation was originally put together. So I was like, oh, that's interesting. So again, just one of those nuances. OK, so let's put together our tests and our code. Again, code on the left, test on the right. In this case, we want to say, hey, we should be calling the scan method when the Bluetooth state changes to on. So in this case, we're setting up our mock. This is literally just creating a new instance of the mock class. We are getting the state. So this state right here is actually a widget state. It's not the widget. It's just the state of the widget. And we want to make sure, we want to go ahead and say, hey, state, we're going to go ahead and run this particular method, update Bluetooth state. So typically, this update Bluetooth state would be called from a listener somewhere else, but we're going to intentionally call that method for the purpose of our test. And we're going to say, I now declare that Bluetooth is on. And we should verify, we want to verify that scan was called after we do that. So it fails because we haven't implemented that. And so this is an example of what it'll look like when you're expecting something and it doesn't happen. It was expecting a particular call to happen. It never did. It instructs you to use verify never if you were intending the opposite behavior of that. But that's just kind of what the output will look like. we're going to go ahead and just blindly call scan. It's OK, whatever. Just when we call that method, let's just run scan. It's probably fine. And test passes. Well, that's fine, but I don't know that we want to call scan anytime the Bluetooth state toggles from on to off, on to off. Doesn't quite seem right. We should add some more conditions in there. So we're actually going to put in a couple of verify nevers, or a few verify nevers, actually. We want to verify, and this might be a little bit excessive, actually, but we want to verify that scan was never called when we construct the object. We then want to call the state init state method. Still make sure verify was never called. We want to then say, I now declare that Bluetooth is off. We have received an update from the Bluetooth library, and we now know that Bluetooth is off. We should still not have any scan calls. And then finally, we tell it that it's on, and then it starts scanning. So we go ahead and run that. This is now the inverse exception, or the inverse message. So it's saying it was not expecting any calls, and it actually got one. And we can go over there and just implement a quick if statement to say, hey, we only want to run scan when it's on.
Similar kind of thing as far as the Java implementation, where you can test the number of times it was called or things like that, at least once or.
Yeah, I believe so.
Times.
Yeah, I believe so. We can take.
No, you don't have to go into that.
Okay.
I'm just curious. Okay.
Yep. Wanted to run through streams as well really quick. So streams allow you to, if you've used RxJava, it kind of feels like that. So it's allowing you to emit multiple values and have something listen to those emissions. So we'll build a test case for a stream commands object. This is not yet in use in the code base, but hopefully will be soon. We're going to build a definition for a stream commands object that will allow us to actually send out those individual messages, and something can be listening to that stream. We want to make sure that when we initialize this new class, that it emits a default value of, this is effectively the stop command. So we're halting any activity on the vehicle, putting it in a stationary spot and straightening the wheels by sending out this command. So again, left is code, right is the test. And in this case, we have the test case, but it's actually async. And we have an await statement right here that's basically saying, hey, we want to go ahead and call our stream and wait for the first element to be emitted. And then when that first element is emitted, we want to go ahead and run this Lambda expression, which verifies particular expectations that it's the correct command that we wanted. Now, when we run this, what do you think is going to happen, other than it fails? How do you think it's going to fail? It's going to time out. It's going to run for approximately 30 seconds, and having never received a first emitted element, it will give up. You'll see a timeout exception after 30 seconds. So at least there's a dead man timer for that. So we go ahead and, all right, so we'll go ahead and add in our default command, again, from our test earlier, just calling the default constructor, calling the constructor with no arguments will just give us the default command. And so that's kind of a quick crash course on streams specifically. OK. Second segment was widget testing. So this is where we sort of start to jump into the UI, kind of. I say kind of because the widget tests don't actually run on they're not running from a visible perspective. So when you run them, there's nothing actually opened in front of your face per se. But you are able to test individual widgets that are appearing on screen. In this particular use case, we want to check that if the Bluetooth is turned off, we just want to give the user a gentle reminder, your Bluetooth's off, you might want to know that. So in this case, we want to verify that that orange stripe is visible. It's a widget called a notice, which we just want to make sure that that's there. And here, if it plays, a quick video of what it would kind of look like. So when you turn on Bluetooth, that should hide away. And if you turn Bluetooth off, it should come back in. So let's go ahead and take a look at that. So I've started to I'm not showing the entire file here necessarily. There's other stuff in there, but this is what's relevant for now. Writing a widget test is very similar to a regular test, but instead of using test at the beginning, the method will be test widgets. And you'll want to give it a lambda an asynchronous lambda at the end with a widget tester object. And we'll go ahead and set up, we'll arrange everything. In this case, we'll mock out the Flutter Blue library. And we'll say, we'll set up some when conditions for some of the methods that are going to be called on that. If it asks about the state of the Bluetooth, then we're going to return a future that resolves to a value of off. And then this is where you actually set up the widget. So this is actually running the widget itself. You're going to call await tester. Tester's the widget tester up here. Pump widget. And then this right here is the widget itself, the device list page content. Now I've wrapped it in a scaffold and a material app. It doesn't seem to want to run without those. So that might be. You'll have to look into based on what kind of widget you're testing. If it has material dependencies, that might be something that you need is to wrap it or just put in your entire app itself. And then we run tester.pump, and then we finally have our expectation at the bottom, expecting to find one widget. So this is an example of the matcher that we talked about. It's expecting to find a single widget that matches a finder. So this finder describes the widget that we're trying to find. In this case, we're saying, hey, I want to find a widget that is a notice widget that has a string of, and then that is a constant value representing the value of the string that we're looking for. All right, so that's started up. It starts up the widget and expects that to be there. And this is what it'll look like when it fails. It's going to say exactly one matching node in the widget tree, but actually there were none. There were no notices. So we go ahead and jump over to the left side again, and we're just going to add that widget in that was missing right there. And running it again, we're all good. All right, finally, last step. So this is the last segment of that chart that we showed at the beginning. Which is the integration section. So this is actually the type of test that will open up your app on screen, or either on an emulator or on a phone, whichever you happen to be using. So for integration tests, you're going to need two files, a driver file and then a test file itself. And the driver file kind of allows you to instrument your app in the first place. And it's very short for this example. We'll show in just a moment. And then the driver test file is actually where you'll describe what it is you want or expect. Running these tests are a little bit different. You'll use Flutter drive target and then the file name. And it's very important that these two file names have the same prefix because I did not have the same prefix before and it would not run correctly. So it's very important that those two files have the same prefix there in the highlighted area. OK, so in this case, these are both kind of test files. Our driver itself is just going to run enable Flutter driver extension. And then you can follow that up with run app. In this case, I want to run the whole app when this starts up. Rotor app is the opening high-level widget for the welcome screen. So running this will literally just start up the app as if I opened it from my home screen. And then on the actual test itself, we're going to say, so we've got this button on the home screen. We just want to make sure that we can click that button. So we're going to go ahead and instantiate our driver, wait for it to connect. And then we're going to ask the driver to tap on a particular, a widget with a particular key. So this key is kind of just an arbitrarily defined string. I'd recommend naming it something that you can remember easily, but it can kind of be whatever you want. And this will be indicating what widget to go find on screen. And then follow it up by just a driver close. And when we run this, it's going to go ahead and say, all right, we're running this test. I'm looking for that widget. I'm trying to tap, and it's taking a really long time. And then we get the same sort of issue where it basically times out after about 30 seconds. It's like, I tried to click it, didn't find it. Don't know what's going on. So we jump over to where that button is located in the source code, and we're just going to add that key that it was expecting so it can actually find the button. And we run it again, and we're golden. So I can try to run this. I have everything set up to run this. This guy's shaking his head up front. All right. Let's see if it's on the clipboard. It is not on the clipboard. OK, so this is in a broken state right now. You see I've taken the key off. It's not there. We're going to go ahead and run this. And then, again, this is going through a whole integration test.
While it's happening, what was the your package convention for your mocks? You throw them under the test directory? Was there anything special you did with them as far as where you put them, or just threw them under the mocks directory?
So the mock definitions are in their own file under test/mocks rotor mocks. And then that's literally just a file with class definitions. Yeah. That's kind of a personal preference. These are mocks that I intended to use many, many times. Not that mocking a lot is a great idea, but these were mocks that I intended to use several times, so I put them in a common area. You could define them just in the test file that you're using itself. And if you see, it did start up the app, and it came out with a test failure, timed out, trying to click that button. So let's go ahead and put in the code change. And now it'll have that key that it's looking for, and we can run that again. And this is kind of, you're seeing firsthand how long it takes to go through individual iterations of integration tests. If this was something like a unit test, it would be run, done. There it is. It'll open up real quick. And it verified, and it's closed. So that is a quick demo of an integration test. One other thing I wanted to kind of loop in at the end here was there is a Flutter developer tools that you can open by pressing, I usually just press F5 to run the app on the device. And if you go up to this corner, it's a Dev Tools button, which opens up in Chrome, and it'll give you a GUI for actually debugging like view layers and all that sort of stuff. Not exactly test-related necessarily, but still very useful. And that'll be open over here, and you can see the widget tree as it appears. So, all right. Again, this presentation and this project was made possible by the Flutter Blue plugin. I'm not endorsed by this individual. I just wanted to cite him. The Rotor project is available on rotor.ai. That's the actual website. And again, my Twitter handle is up there. Any questions? Yep.
How long has those dev tools been around? The one that you just showed? Has it been a while, or?
It was around in April of this year. That's when I first heard about it. I think this button over here is kind of new. But yeah, I think they introduced it like in spring of this year. Nothing else? OK.
All of your test files have a main in there, a main function.
Yes. Yeah, so you can run, this is just from the root folder of the app. I can run Flutter test, and that'll run the whole suite.
Will it just recurse through all the files and they're looking for ones with main?
Yeah, I believe so, yeah. Oh, real quick, there was also one other thing. You can run Flutter test coverage to get code coverage metrics. I'm not sure how to interpret the files, but it will output a new directory called coverage, and it'll give you information. That I took a look at it. I can show it real fast. So coverage ls. It gives you a lcov.info. And I presume they've got something on their website for how to interpret this, but you can get code coverage information. So it's got test file names listed there.
It is a little cryptic.
Yeah.
You can probably throw that into any coverage tool that supports LCOV.
Okay.
Hot reload?
Yep.
Anything like that for running your tests?
That would be cool. I haven't looked into that. I know there is something like that for other, like for NPM, for example, for like writing TypeScript tests. You can do a watcher, and then you can just like write your tests, wait a second, it fails, write your implementation, wait a second, it passes. I don't know. That would be an interesting thing to look up. I know I definitely enjoy it when I'm writing TypeScript, though. So. Cool.
Widget tests, I presume. I think they have to run in the emulator.
Just your whole entire test suite?
Yeah.
Or just your unit tests? 'Cause the other ones are slower.
All right. Thanks, everybody.
Wait.
What?
I'm writing these down. So like all the Flutter examples on the website follow like the burrito pattern, where everything is just stuffed into one widget and whatnot. What strategies do you use for separating that out?
For widget testing?
For like pulling out, you have your commands there.
Organization of your project.
Yeah, like what kind of architectures do you use to for yourself do you prefer?
So the one I was kind of using for this is a very small app in its current state. I kind of was separating it as follows. So I would have a welcome page. I'd have a welcome folder. That welcome folder would have a content widget, and within that content widget, it would actually have, it would have a page widget, which is a stateless widget, which uses a scaffold and then contains the body. So this is like kind of sort of mimicking the activity fragment style that you would sometimes use if I just have a basic page. I just want it to be an activity with a fragment, but in this case, we're using
What
widgets.
methods do you use for like interfacing with your business logic? What's your architecture of choice?
There's not a great deal of architecture with this particular app. On the professional scene, I would usually use something like MVP, Model View Presenter, or MVVM. In this case, and again, with this particular project, there isn't a back end that we're talking to. It's really just a local connection from our phone to the rotor vehicle. I did show the streaming class, and that is kind of, sort of, I guess, in the business logic realm. That would be kind of an intermediary between creating a command and then sending it over to our command streamer, and then the command streamer has listeners that would then send it over Bluetooth. So, thanks.